Hi, and welcome to centripetal motion help. I think most of you that are having difficulty with this, it's probably using the equations and rearranging them with some algebra. So what I'm going to do is I'm going to take the equations, which you should have listed on your equation sheet, and I'm going to show you how to rearrange them for different variables that you're looking for. Also, you need to make sure that you've made yourself a chart where you put down what the variable is, what the quantity is that it measures, like velocity or period, and the unit that it has to be in, like seconds or meters or kilograms. So that's what I'm gonna do. Should be about 10 minutes to try to get you to figure out how to use the equations. I will just briefly, so that you can pause it if you need to. These are the equations. I don't know if you can see that or not. If I have it pointed the right way. These are the equations that should be on your equation sheet. Also, you might want to have the mass of the Earth and the radius of the Earth, and you can put the mass of the Sun, that's the other number that's on there, but if you need that for the test, that'll be provided. But the mass of the Earth and the radius of the Earth will not. So if you look at the equations, the first three are from the last chapter that we added to this chapter, which was centripetal acceleration and centripetal force. And so this is like the experiment you did where you twirled the stopper around your head. And so when you look at that equation, this is the tangential velocity. So as the stopper was going around in a circle, it had a velocity as it went around the circle equal to the circumference of the circle divided by the amount of time to go around once. And then from that, you can get the centripetal acceleration and the centripetal force. So if you have not already done so, like I said, make yourself a chart. This is the tangential velocity. It has to be measured in meters per second. 2 pi and r, 2 pi are just 2 pi. R is the radius, it has to be in meters. If you're talking about twirling something around in a circle, it's the length of the string. If you're talking about the moon going around the Earth, then it's the radius of the Earth plus the elevation of the moon, unless they tell you the orbital radius. So this is the radius of the circle. And this is the amount of time to go around once. That's what the t is, and it has to be measured in seconds. So this is the acceleration, it's measured in meters per second squared, and then the force, as always, is measured in newtons. So these are the first three equations that we used in chapter 6. Make sure, the mass has to be measured in kilograms as well for the last equation. I don't think that there's one on the test where you really have to rearrange this, you just have to be able to use them. So be able to pick out the information from the word problem and then put it down. I don't think these are the three problems that are the most difficult. I think it's the things from chapter 7 where we started talking about gravity. But all of those equations are pretty much, they have the same variables in them. So if you look at the equation for force, the force of attraction between any two massive objects is equal to the universal constant. And they're never going to give you that in the problem. You have to know that this is 6.67 times 10 to the negative 11th Newton meters squared per kilogram squared. And then the mass of one object, the mass of the other object. This could be the moon and the Earth. This could be you and your friend sitting next to you. This could be Saturn and the sun. It doesn't matter, but they have to be measured in kilograms. And then the distance between their centers is what goes in the denominator, and that has to be squared, and it has to be in meters. So sometimes you have to rearrange this equation. What I always do is I multiply both sides by r squared first, just to remove the denominator because fractions are evil. And then you can solve for whatever you want. It's just algebra with weird letters. So let's say I was solving for one of the masses. What I would do, algebra. Anything divided by itself is 1. That's why they go away. And so now I've solved for one of the masses. But once you get it to this point where you have r squared times f equals g times m1 times m2, you can solve for whatever you want. If you want to solve for the radius, like I said, I always, regardless of what I'm solving for, I get rid of that denominator. So now I've got fr squared equals g m1 m2. So let's say they ask me for the radius of the Earth. They give me my mass, they give me the mass of the Earth, they tell me what the force of attraction is, which is basically your weight, and you want to find r. You do it the same way I did the other one, algebra. You divide both sides by f. That makes the f cancel out on the left side because anything divided by itself is 1. And then algebra is just doing the opposites. This was multiplied, so I divide. So r squared, the opposite of squaring something, is to take the square root. If I take the square root of one side, I have to take the square root of the other side. So the square root of r squared is r, and then you have all of this. You really, really, really need to solve with the letters first, because these are very strange, large numbers. Also, when you go to college, you'll be mocked if you don't solve first with just the letters. I'm videoing, I'm sorry. So that's what you're gonna do. That's how you do that one. The other one I think that people had difficulty rearranging the equation for was the period. The period is the amount of time it takes for something to orbit. So this is what the period is, a tau, and the equation is 2 times pi times the square root of r cubed divided by gm. Once again, g is that weird number, 6.67 times 10 to the negative 11th Newton meters squared. If you start putting numbers in here, it's going to become very cumbersome. So solve first. Let's say we were solving for m, mass of Saturn, or something like that. The easiest way to do this is to divide both sides by 2 pi first. And that's going to leave me with this. I need to get rid of that square root. So I do the opposite of square rooting. I square. If I square one side, I have to square the other side. Everything has to be squared. The period squared divided by 2 squared is 4, pi squared is pi squared. That's going to equal r cubed over gm. Now I basically have 2 fractions with an equal sign in between, so I get to cross multiply. So t squared g times m equals 4 pi squared times r cubed. Get rid of fractions. Fractions are awful. Now, if I get it to this point, I can solve for whatever I'm looking for, but I said I was going to solve for m, so that means I divide both sides by the variables I'm trying to get rid of. Now I stick all the ugly big numbers in. So I think the major problem with doing these word problems is the algebra. That's what I have found. We're having a hard time switching things around, especially for those of us who put the numbers in first. If you put the numbers in first, that's going to be problematic. Hopefully on the review, we can do better. If you have individual questions, you can always message me.